we'll try to see if we can meet the expectations of the audience here. So first of all, it's my esteemed pleasure to be here talking on a very topical topic which is just buzzword everywhere, right? Agentic. Are we preparing ourselves the way we should prepare ourselves to go to the next big leap that Agentic is talking about, right? So far we have seen, I heard a lot about generative AI, which is generating text, which is analyzing a lot of data. But the next big leap is Agentic, where it is not just analyzing the data, it is not just extracting the information, it is not just generating the images, so on and so forth, but also it will have the capability to define objectives, take actions, and act like a human, right? So this agentic leap is coming now. Are we really prepared, or what we should do to get prepared there? Right? So we are talking on this topic, and with me I have a very esteemed speaker, Mr. Pranay, who will, I would say, enlighten us on the topic today. He is Deputy General, Senior Vice President, Hitachi, India R&D Center. So we look forward. Right? The key things that we'll try to discover: how is agentic different from what we do today? That is one. Second, if it start to make decisions like how human do, what are the controls that we need in place? Right? And third, are there any safeguards that we should keep in place when we are moving to this big agentic leap? Right? That's third. So let me start with Mr. Pranay on the first topic, right? So, Mr. Pranay, if you could first enlighten us, what we do today, how is that different from this agentic? Is this more like incremental to what we do today, or do you think it's a big paradigm shift that we are moving on?
That's a very nice question. But before I answer that, let me first introduce me and my organization to the team here. So I represent Hitachi. Hitachi, as we all understand, is a Japanese conglomerate and very popular in India for the air conditions or the table fans. But we've had a very long association with this country. Like, the first steam engines were provided by Hitachi, and also the Bhakra Nangal dams, the turbines came from Hitachi. And since then, we have been pioneering a lot of technologies. Now we do railways, we do financials, we do data centers. Now I'm here more to talk about data centers. Now, the question that you ask, what's going to happen in the future? We talk about AI data centers. What exactly is an AI data centers? Clearly, the world is moved beyond traditional, PLC-based management, more in terms of Linux, RT Linux based. That means we are going to generate more and more data, right? And while we do so, the system itself is becoming more powerful too and capable enough to analyze the data at the edge. That's why the agentic systems comes in. Now, when we empower facilities, we give them more flexibility in terms of being more autonomous, at the same time being more federated, right? So there is a difference. You are centralized, you are autonomous, and you are federated, which is in between. Now, most of these agentic systems, they introduce a completely different shift from how to be managed today. Now, take a case of point where we are running an AI systems. Most of these AI systems are trained, right? So they are trained offline, and then they are deployed to do the certain tasks. In case of agentic systems, they may be training at real time, right? And they may be finding better negotiations with the other agents. Now, what does that mean in terms of data center operations is, you have to be prepared enough to have very flexible or elastic resource management. Today, we have power systems which are static. We have your network based on bandwidth. But going forward, we have to also think about how do we bring in more flexibility in terms of not only software defined, but as a service model, on-demand model, right? How do we bring in network on demand? How do we bring in internet on demand? That was the term the lady used over there, that's right apt term for that. So everything becomes in terms of elastic resource management. And also from a security viewpoint, right? Now, as and when we bring autonomy in certain systems, we have to also define in terms of how do we monitor them. How do we make sure, what are their safeguards, what are the guardrails against which we are making, letting them do autonomous decisions, right? So let's say, take a case of point. We have a system which is kind of negotiating with the other system in terms of power utilization. Let's say how much should I cool and how much of power I should extract from the grid. That is the level of autonomy we are talking. if an agent is invoking another agent, what are the conditions, what are the ground rules? And how do we make sure that our agents are not spoofing, right? These are not our rogue agents. So there are multiple conditions around how the operations should do, how our security should be designed. We call zero trust. Zero trust means principally, I'm not trusting anything. I have a guardrail for every activity that you do. I'm logging all of your activity. I'm making sure that all the activities follow certain patterns, and these patterns are familiar to us. Any anomaly in those patterns is something that has a human in it. Those kind of things are changing the way we operate. Governance layer will change. So overall, the new set of systems is going to be more elastic. They are going to be more on demand, and they are going to be more at the edge, right? And if you look at India as an emerging market, when we say emerging, what emerges here? Our biggest advantage is land. We have land, so we can really build data centers, unlike other Asian countries which doesn't have land. So, so they're looking at more distributed data center management. But as we have land, we have resources now. We have energy will be our largest bottleneck. Now, how do we play between a containerized data centers versus a hub data center model, and make sure that these agents which are running at the edge are able to communicate with these people? How do you monitor those? How do you provide resources on demand? How do we increase the bandwidth? So those are the things that, as R&D, because I represent the corporate R&D, we are already working on technologies to enable it. And I'm sure those kind of things will see to light in the next 2 to 3 years.
Great. So, you mentioned on two important words which are like the core of what we are doing in Agentic, right? One is autonomy, and the second is making decisions in real time. I'll talk about these. I think you gave examples, but maybe more double click on this. So first of all, autonomy, right? Now we say autonomy without traceability is a liability, right? If you are making machines to make autonomous decisions and you do not know why the machine made that decision or why the agent made the decision, it is a liability, because then you might be in a big problem. So how do you balance this autonomy, traceability, index? Are there examples from your industry that you would like to give to them?
Right. I think this has always been the case. For example, in your organization, when you take a decision, you back up with the data, evidence, right, why you made a decision. Same thing happens with systems of today, system or systems, if you take. Now, fundamentally what happens in these systems is, when AI agents, which is AI, artificial intelligence, right, they have to give explainability to all their acts. Explainability comes from the fact what are the choices they are making. Now these choices are not completely autonomous in nature. They are based on grounding, strategies, rules, whatever you call it. In terms of technology, we call it grounding, right? We provide some strategy grounding. In terms of data center, it would be more in terms of what kind of architectures are we creating, right? How are these agents in terms of an east-west network, how are they coordinating with each other? And if an agent is invoking another agent, as I said before, what were the information shared? What were the decision factors taken into account? From an accounting perspective, we have to create those framework in place. And even from a networking perspective, we have to have more high bandwidth, low latency within the data center communication to facilitate more agentic behavior. I'll give you an example of what is an agentic AI ecosystem. You can consider total energy management or total cooling management. We have a lot of CDU companies here. But when we talk about, let's say, coolant distribution units or managing the coolant within the rack, we are looking at very local operations. But we are not looking at what the chiller is doing. So now if you can imagine a system where you have all these agents, chiller as an agent, CDU as an agent, server as an agent, and all of them are negotiating with each other on one problem, which is a thermal imbalance. But that's a negotiation. Now everything has to work in a particular set point. But what essentially these agents are doing is they're negotiating in a multi-party way, right? They're negotiating with each other so that there is an optimal state in which we are maintaining the overall KPI. Now, in order to do that, we need to ensure that the system is configured or wired enough so that this communication is happening without actually disturbing the workload. The data centers are for managing the workloads, right? If we are expending more energy in terms of giving more power to these agents to do governance activities, what do we really achieve at the end? Nothing, right? So those are the questions that we should ask, and we have to really qualify an agentic AI application. Qualification is the term. It's not like that we carried away with a wave and start implementing across quantities and everything. We should really qualify whether we do really need those systems or not.
No, very apt point. And now let me go to my second point that I was talking about, which is real time. So what I mean by real time, before I ask question to Mr. Pranay, let me just give my expectations on real time. Let's say someone from a bank is standing in front of me. They have a edge device, mobile device, and they're asking me to apply for a credit card. The moment I fill my application, how many seconds does it take to tell me that my card is approved or not, right? Now what is happening? For us it is just a message that your card is approved or rejected, but in the back end, your information is taken. It is passed through some rule engine. It is doing some checks with regulators like CIBIL, checking your CIBIL score, checking your financial stability, checking whether you are part of any fraud database somewhere, so on and so forth, checking if you have any account which has gone into NPA status in the bank, so on and so forth. All these things which I mentioned are agents running on the back of this question which went to the mobile, right? And once all these agents said, no, pass, then there is a supervisor which is listening to all of them and saying, okay, card approved. And that one person is coming in, is screening the message on your mobile saying that card is approved, right? So this is real time into me. So if you put up a question, say submit, it probably takes 2-3 seconds to tell your card is approved or rejected. Now in this world where user and consumer wants the power on mobile, right? They want to feel everything on the mobile in real time. And we're talking about agentic, which needs large compute. We're talking about big data centers. We're talking about quantum computing, so on and so forth. So how do we balance, which obviously can't be done on the edge device, right? It has to happen on the cloud or on the data centers. So how do we balance this consumer behavior, asking for things in real time, using agentic, which will leverage large calculations, etc., which will happen on a cloud and then it can't be done in real time. So is there a balance between this?
Yeah, so the statement what you made, the use case that you explained, so there are two set of problems that needs to be solved. One from an operator perspective, the more data points we create, the more cost of operations will increase, right? So we had this problem when we were working on some speech recognition technique, right? Now what we try to solve is, if you are capturing the speech data and storing it, as you know, any application, digital application, 40% of the cost is my data center cost. Now naturally, I would want to save on that. So I built a low quantized model. Let me use the processing capability. Everybody has a fancy phone now. Let me use the processing capability of that phone. So that solves one of the problems. How do I offshore most of my analysis work towards the edge, right? And even for the low latency systems, what we see today is, from a governance viewpoint, you want centrally orchestrated activities, right? As you said, you want to ensure you meet your standards for CIBIL guidelines. You want to ensure that the person is onboarded through some account management activity. So all these are centralized functions. What is not centralized is, for example, taking the information, verifying that the user meets, the picture meets the person, right? It is not a fraud person. So all these things can move towards as closer to the edge. So from an system architecting perspective, I look at how do I use the resources that is available to me? Can I have certain things run locally to this user's applications, right? If it is not running locally to the user application, what is the nearest? Can I run it at the gateway? So most of the applications today, the agentic system that we talk about, they are running at the gateway. Because the gateways have also matured, they are beyond PLCs, they are running now RT Linux. They are running RT Linux, you can have applications running on top of it. So as a solution architect for this new kind of systems, I have to ensure that how do I reduce my burden on the centralized authority, but at the same time I have accountability, traceability in terms of what each my individual functions are doing, to have that bird's eye view of your entire system operations, and then be able to make certain decisions in real time. Right? Now this sounds a very simple statement, but trust me on this, when we are designing for that infrastructure, right? it takes a lot in terms of planning your infrastructures. Now there are three big large components for any data center planning: your compute, your network, your storage. Power and other things are retrofitted with your EPC players and things like that. So, but as a system, as a cloud provider or as an application owner, these are the things that we have to take into account when we are defining the constraints of this.
Great point, Mr. Praveen. So I have my last question, but and I can definitely go and ask it, but I just want to check if anybody from the audience have a question they want to ask, which is in their mind. Because it's a topic which everybody is talking about agentic, right? So if there is a question you want to ask Mr. Praveen, I'm also here, I can answer, but I have my last question for him to ask.
Thanks. Amit God from this side, from WST. Yeah, I want to ask, as you have mentioned for credit card from backend, there may be some agents. One agent is checking that this customer is from. One agent is checking that all deal. So always there should be some multiple agents in backend or one agent which is doing end-to-end tasks.
Yeah, it depends upon what you call as a singular agentic function. Now, typically, an agent is, we had microservices supposed to service something independently, running on some kind of a cloud environment or some kind of a containerized environment. But now in agents, we call an agent or qualify them as an agent. One, if they are able to sense themselves. Second, it is able to take certain decisions on their own. Third, it is able to change its behavior based on. So today, if any of my development team they wants to write an agent, it's zero coding. You cannot predict what will happen today, right? So these agents have to ensure that they are able to train themselves, be able to operate themselves, and be able to correct themselves, rectify themselves. The other thing what we are seeing is, as I said, centrally orchestrated architecture is moving to more federated or more decentralized in terms. These agents are now able to talk to each other through A2A protocols or MCP protocols. And this is when the real autonomy takes place. Now the agents are communicating to each other, reaching some optimal state. And so less governance on the federated entity, right? So it's all upon, how do you qualify your agents to be. But at least these three functions should be part of the agent.
Yeah, and maybe sorry, I didn't capture your name. Amit? Amit. So visualize this, right? If there were no agents, there was no machines, how it will happen in a real time, right? In a big office, there is a team which is looking at the applications, which is called your application processing team. There is a team which is checking your civil scores, financial stability, so on and so forth. There is a credit risk team which is approving the credit cards, right? Each of these agents that I was talking is doing nothing short of just mimicking each of these teams. And then there is someone who is head of this team, which will nothing but be a supervisor agent. So supervisor agent will tell the extraction agent to extract the information. It will then ask next agent to do it, and so on and so forth, right? And then supervisor agent gets the message back, passed back to the screen. So this is specific screens, like he was saying, right? We were doing it. Microservices is what we used to call it. It is now all those microservices are getting replicated by agents, what we're talking about. But great question. Thank you.
Thank you so much, sir.